So this is a teardown of a Makerbot 5th gen mini 3D printer. I'm just purely doing this out of curiosity. I haven't seen any videos like this online about the 5th gen Makerbot machines. You can see here I've taken it partially apart. This is the smart extruder here. And I just wanted to talk a little bit about what I discovered when I opened up the machine. The machine is an HBot configuration, like most Makerbots. You can see here the X and Y axis are driven by NEMA 14 stepper motors. NEMA 14 stepper motors. And they travel along a rail.
You're still working at that thing?
Yeah. You can see the... Oh, I'm just talking for a video. You can see the gantry here. It's a metal gantry that holds the carriage and extruder mount down there. There's no bearings as far as I can see. I just believe it's a friction rail that moves along here. These are GT2 timing belts, pretty standard stuff for a 3D printer. And you can see the X-axis right there is just a mini slide rail. This bracket here holds the extruder carriage in place. The Z-axis is driven by an 8mm lead screw. You can see there it's attached directly to a NEMA 14 stepper. This is the Z carriage here. It's just pure molded plastic, I would guess probably ABS. You can see there's an embedded lead screw nut there. In lieu of linear bearings on the Z-axis, they have a kind of gear system, I guess, that travels up and down. It's a plastic gear, and yeah, I don't really know what to say about that. You can see there's the gear rail that guides the Z-axis up and down. This here is the XY carriage that houses the electronics for the extruder. I was a little bit surprised to see a NEMA 17 here for the extruder. And you can see there's a little PC board which I believe communicates with the smart extruder. There's the interesting pin connector there, which is held in by neodymium magnets on the smart extruder itself. There's a connection collar here that connects the NEMA stepper to the extruder itself. I've seen diagrams of this online. I believe it's mostly plastic gears on the inside. I haven't been able to get the power source out. It's stuck behind the Z axis here. A lot of this is held together with pull tabs, so if you take it apart, there's not much hope of getting it back together. Probably very easy for assembly, very difficult for disassembly. This is the control board here. You can see it's not a mighty board from the last generation. It's a new revision of the Makerbot PC board. I haven't really been able to find any good information on this, but it does have an ARM processor. So this is some RAM, I guess it's for driving the processor. This is a Bluetooth connection module, and yeah, pretty standard stuff. You can see there's a camera here that I will attempt to liberate. The frame itself is all injection molded plastic on the outside. Feels like ABS. There are some internal metal used for the structure. You can see here the tray that holds the PCB and the forms the bottom support is folded metal with some threads. A lot of the chassis is held together with these Torx screws, so you're going to need a special toolkit to get these apart. A lot of the plastic components are held in with tabs, so like I said, once you take it apart, it's not likely to come back together again. So you can see here with a little bit of patience, the injection molded frame can be removed, and that holds the y-axis. These metal sliders that are embedded in the plastic up there. You can see that the support for the z-axis, which is here, is bent sheet metal. And this is what it looks like taken apart. So bent sheet metal that holds the bottom plate and the back plate. So the nylon screws in this are quite factory tightened, so they're liable to strip when you're trying to take them apart. And how tight are they? Well, the grip on my Shenzhen Torx driver has completely delaminated trying to remove them, so I can't even. As you can see here, there's another breakout board on the inside of the frame, and this provides the power and signal to the camera. And there's a connector for a stepper motor here. It's a status LED underneath this piece of frosted plastic, and this tab just connects to the bottom metal sheet, presumably to provide a grounding connection for power. So here's the freed camera module. Pretty standard stuff. The same kind of PC board camera you see all over the place on AliExpress. Things like that. Nothing really to write home about, but still worth saving. So here's a better look at the X-axis gantry. This here is some kind of, again, folded metal. A pretty decent little linear slider here. And just a close-up on the idlers here, you can see they're just plastic pulleys with what looks like metal bushings on the inside, no bearings to speak of. And here's a look at the y-axis again. No bearings. What you have is this metal extrusion here, and this plastic sled just sort of fits into it, and it slides along like that. It's not a great deal of friction, as is. This is what's holding in the power supply. Again, you can see before I even had a whack at it that these nylon screws from the factory were pretty well stripped getting put in. You can see it transforms your standard 100 to 240 volts AC to DC power. That's what I'm trying to get at right now, the DC power supply. And you can see a little funny detail underneath the injection molded foot here. You can see a pile of PLA that's accumulated underneath somehow. Just this merry little pile of PLA just hiding out in this foot. So this is the inside of the Smart Extruder. You can see they use the same shortened pancake style hot end that you see in most Makerbots. Pretty standard design. I believe there's some kind of spring on the bottom here for a touch sensor. That might just be on the 5th gen. I don't know if that's a feature. No, there's a spring here. There's a spring here for that. Quite a few plastic parts. You can see here the extruder lever arm itself. Pretty non-standard design. I believe this bearing pushes on the hobbled bolt down here, grinding its way through. There's an extra wheel here, which I think might be a filament sensor of some kind, maybe a rotary encoder. There's definitely some kind of extra little sensor back there. I can't get to it, but there's a little sensor behind this wheel. I've got the board out here, the sensor board. It connects the little 4-pin header connector there. On the end of it is sort of a curious mechanism. It's a little spring-loaded kind of tack switch style thing. Maybe it measures the force of this plastic wheel here. I'm not totally sure about that. One neat little thing about the PCBs is they're all named after different neighborhoods in New York. Some more neodymium magnets. Those are pretty good. A couple of bearings that can be harvested out of this. Another mystery reveals itself. We've got this, some kind of metallic film on this wheel that it was hitting up against this spring-loaded sensor here. Presumably that sits on there like that, and depending on its state, maybe it counts it using some kind of light sensor. The rotation counted using a photocell or something like that. I don't know, any ideas what that could be? So I did a quick look online, and this is indeed the filament presence sensor. So I guess the filament comes through the top here, and as it passes through, this little tag switch is depressed and lets the board know that there is indeed filament. It's kind of thin and small though. And again, I noticed there looks like there's little, I would guess these are LDRs or some kind of photosensing diode here, maybe an IR pair. And my guess is it would gauge the speed in which this is turning, and that's the filament jam sensor. So I think the idea is if presence is detected on this sensor, but this wheel isn't turning, that would count as a filament jam. As you can see here, this appears to be perhaps the cause of this printer's death. Something has certainly let out the magic smoke on this board here. Yeah, these nylon screws are totally stripped, so in order to get this out I may need to take a drill to it. I'm assuming it's some kind of, you know, AC to DC power transformer adapter. I mean, it's very similar to like an ATX style connector that connects to the PC board here. So overall, what's the Makerbot Mini's e-waste potential? You've got a couple of NEMA 14 stepper motors that can be used for a number of different hobby and 3D printer projects. If you can get it out, there's probably a fairly good 12-volt power supply on the inside of here. There's one NEMA 17 stepper attached to the extruder, which is useful for 3D printers. A couple of fans. These blower fans are useful if they still work. And you've got one generic PCB camera module. Aside from that, nothing like bearings. I mean, you have a couple of idlers that can be used. I don't really see a huge use for this NEMA 14 Z-axis. In a rep wrap, generally you wouldn't want to use something like this. And you can see there's quite a bit of grinding going on there as well. So overall e-waste potential, I would say okay, not bad.